Welcome to our second hydrocarbon, the haloalkanes, or like I call them, the halogen hitters. They're going to be ruled by the bromo bond. And this family is going to be thriving on the reactive potential because they have the skilled ability of replacing hydrogen with halogen. And once you replace them with those halogen, you get reactive, okay? Leaving a trace of all their power behind. Now, some of the functions we see can be in the form of anesthetics like chloroform, paint strippers, air conditioners, etc. And guess what? The naming is similar to alkane. So when I tell you when it comes to naming, it's all about layering things. We're going to have our prefix, our root, our suffix. We know how to name alkanes. Now we're going to take what we know about naming alkanes and switch it up a bit, okay? So haloalkanes are going to be similar to naming alkanes, except the prefix is going to change, okay? And also, another little caveat. The carbon chain is numbered from the end closest to the halogen. What does that mean? That means that when I see this 3 carbon here, I see a halogen and I see some type of alkyl group or a methyl group. When it comes to numbering, I want to make sure that I'm numbering closest to where the halogen is because it's seen as its own little functional group to be able to create this group itself. So I would number 1, 2, 3, or from this, because it's equal distance, 1, 2, 3 that way. Now here, we have 4 carbons, right? And we see bromo and chlorine, 2 different halogens. And so when you're going to be numbering, you want to go and number next to the one that is in alphabetical order. So in alphabetical order, B comes before C. So we're going to number with bromo first. So I would say 1, 2, 3, 4 carbons instead of naming it any other way. Okay. So the carbon chain is numbered from the end closest to the halogen. Also, with the prefix itself, you're going to be using different halogens and they're going to change your prefix. So the prefix will be like fluoro, chloro, bromo, iodo, instead of like methyl like we've seen before. Okay. All right, so we want to start like we would an alkane. All right, so we have our prefix, our root, and our suffix that we're trying to get to be able to get our organic compound name. Okay, then we start adding the little details. We know the prefix is going to change, and it could be bromo, it could be chloro, whatever halogen that you're using, you want to make sure that you have the correct prefix there. Okay, so that's going to help us with the prefix information. We also want a number closest to where the halogen is. So in my first example here, I have our bromine. As you can see, it's the same examples from before, just so we can go ahead and do them. I have my bromine, so I want to number this 1, 2, and 3. It didn't matter if I numbered it that way or if I put the carbon 1, 2, or 3 here. Either way, this bromine is on carbon 2. So I need to make sure that I have my bromo as well. But before I write my prefix, I want to do what I did before. I want to write my root and my suffix. There's 3 carbons here, so I know I'm going to have pro, and there's only carbon hydrogen bonds, carbon-carbon bonds, and carbon-bromine bonds or carbon-halogen bonds. They're all single bond. So that means I'm dealing with ane, okay? That's going to be propane. I got my root and I got my suffix. Now, we also know that we also are going to have to take into consideration any substituents that we have attached. So we have our parent chain here. We'll have to circle that. And then we have 2 things that are attached to the parent chain. We have the methyl group and we have the bromine. Now the bromine we know is going to be a part of us naming the haloalkane. And the bromine is going to take precedence over any of the alkyl groups or any other substituents. So when you have halogens, it's going to take precedence over any other methyl group that is attached as well. Okay, so just keep that in mind. And the bromo or the halogen is going to dictate the name. So bromo is going to come before methyl, right? So bromo, we're putting everything in alphabetical order. So we're going to have our bromo. Now, again, one little task is if we have our bromo, we have to have a location because it's in the prefix. Now, what carbon number is this bromo on? Carbon number 2. So we're going to have 2 bromo here, okay? Now, we also have to consolidate this methyl group here. So we have 2 bromo, same carbon, 2 methyl propane. There we go. Let's try another one. So first, we got to get our longest carbon chain. Okay, this one is going to be 1, 2, 3, 4. And you got to tell yourself, how am I going to count this? Well, I can count carbon 1 here, 2, 3, 4. But it's all going to be depending on what's attached to our parent chain. So we have bromo and we have chloro. So that means we have 2 halogens. We have to put them in alphabetical order. Bromo is going to come first. So I'm going to number 1, 2, 3, and 4. Okay. So 4 carbons is going to give me butane, but for my root, and because I only have single bonds here. So butane is what we're looking at here. All right, folks. Now we know we're going to have bromo. That's going to be first. So we're going to have 2 bromo dash 3 dash chloro. And that will be our name. And I do want to say that, yes, as you go higher in organic chemistry, you're going to learn way more details about how we can name different compounds. And also, you won't just see haloalkanes. You can see haloalkenes, or you can see basically haloalkanes with double bonds, triple bonds, et cetera, et cetera. Okay, folks, that's what I'm trying to say.